Good morning. I'm going to go over today assignment number 10, Intro to Dead Reckoning Plotting. So I already have it plotted out, but I'm going to go over step by step how to do the worksheet, and it's really a practice of using our speed, distance, and time calculations. So that's 60D Street formula. I'm going to do both the magic circle and the formula. So let's get started, and I will walk through this assignment with you guys. Okay, so we're going to start with number 1 on assignment 10. And it tells us we are cruising from Newport, Rhode Island, up around there, to Martha's Vineyard, all the way across the chart. At 8:20, you depart Breton Reef Light. That's right here, Breton Reef Light. It gives us a position and set a course for Buzzard's Light at a speed of 6.5 knots. So here's Buzzard's Light. So I've connected the two, drawn a line, and it told us our speed was 6.5 knots. So we want to figure out, first step was to draw the line, connecting. And then we want to figure out what our true course is. So if we use a triangle, we can put that triangle on the line in question and the focal point on a meridian. Then we could read at the bottom what our course line is. So we're going this way, so this is 090. And this is 100, and so we're in between at 096 for our course. We can also use the parallel rulers or the roll plotter by putting our roll plotter right on the line, and then just bringing it down here to the compass rose. I know I'm a little bit off the page, but you can do that as well. So now we have our true course of 096, and that wants us to put in our DR positions. So we left here at 8:20, and we want to do a DR on the top of the hour, and then either every hour or half hour. In this case, they asked us for every hour. So if we left here at 8:20, our next one we'd need is 9 o'clock. So I need to figure out from 9 o'clock how much time has passed to get to from 8:20 to 9 o'clock. So that's 40 minutes. So now I have my time of 40 minutes. My speed was given to us in the problem at 6.5 knots. And our distance is what we're looking for, so we can plot our DR line. So we need to go to 60D Street, and I will do the formula here. So we have 60D Street, and we want distance by itself. So we're going to move that 60 over to this side. So we get D equals S times T divided by 60. Now I can plug that in, my numbers in, and I get a speed of 6.5 times a time of 40 minutes divided by 60. What does distance equal? So I could bring out my calculator here, and I can say 6.5 times 40 divided by 60 gives me 4.3 nautical miles. Okay, so now I'm going to get my dividers, or my compass, whatever you choose, and get 4.3 nautical miles. So here is 4.3 nautical miles, and I'm going to start it on Breton Reef Light, and then put a little mark, and make my 0900 DR position. So now that I have my 0900 position, it will be easy to get my 10 o'clock position because it's 1 hour. And a knot is a nautical mile per hour. So if we are going 6.5 knots, we would go 6.5 nautical miles in 1 hour. So I'm going to get 6.5. Alright, so I have 6.5 on my dividers. I'm going to start at my 9 o'clock and go 6.5 and say that's where I'll be at 10 o'clock. That's my 10 o'clock DR position. And then if I go another hour, where am I going to be at 11 o'clock? I'm going to be past Breton or Buzzard's Light. So I know from that my ETA to Buzzard's Light is going to be in the 10 o'clock hour, probably past 10:30, but before 11 o'clock. So that's a good mental check to do. Because our next problem is to figure out what our ETA to Buzzard's Light is. So it asks us what is the distance of this entire leg. So I like to do that by going (5 miles) is on my dividers, and I go 5, 10, 15. So 15 plus whatever this is. (15 plus 1) gives us 16 nautical miles. So my whole distance, so this is 20. I'm going down to Buzzard's Light, and I have a 9 o'clock, a 10 o'clock. So my entire distance on this line is 16 nautical miles. So it asks us what is our ETA. So I have distance, I have my speed, I need to know what my time is. So I go back to, so we have distance, speed, and time. Distance is 16 nautical miles, speed is 6.5 knots. My time is my ETA, and that's what's in question. So this time I'm going to try doing the magic circle. See if you guys like that one. Okay, so we can put in our numbers for D is 16. Speed is 6.5, and T is our question mark. So on our calculator, and this is 60, always 60. So the two things that we know are actually on top, so we multiply those and then divide. So on our calculator we can do 60 times 16 divided by 6.5. And that gives us call it 148 minutes. So then I need to make my 148 into hours and minutes, because that's a hard number to work with. So we have 148 minus 60 gives us 2 hours and 28 minutes. So if we left here at 8:20, what is our ETA to Buzzard's Light? So we have 8:20 plus 2 hours and 28 minutes as our transit time. We always do the minute side first for 48, and then 8 plus 2 gives us 10. So our ETA is 10:48. So that was number 3. And then it also asks us for the next part of the question, which is what we already did. What was the distance that you've traveled to 0900? We had calculated that to 4.3. And then asked us what was the distance to 1000, and that was 6.5. But from 8.2, we can add up those two numbers to say our total distance from, how am I going to draw this? From 4.3 to 6.5 would be 10.8. Okay, so for the next part of the question, it said you arrived along Buzzard's Light at 10:35. Using the actual time, determine the speed made good. So our ETA that we calculated for Buzzard's Light was an arrival at 10:48. But we actually got there at 10:35. So, from looking at this, I can see that we made better time, that we got there quicker than expected. So I can see that we made some good speed, more than 6.5. But we want to know what our speed made good was. So on average, from point A to point B, what was our speed made good? We thought it was 6.5, but we got there a lot sooner. So what actually happened? So in order to do that, we go back to our distance, speed, and time calculation. So our distance we had calculated to be 16 nautical miles. Our speed is what we're looking for. What was our speed made good? And our time was from 8:20 to 10:35, because that was the actual time we got there. So we need to do a 10:35 minus 8:20 calculation to get what our time is. So we have 35 minus 20 gives us 15, and 10 minus 8 gives us 2. So it took us 2 hours and 15 minutes. We have to make that all in minutes. So we have 120 plus 15 gives me 135. So I have 135 minutes at 16 nautical miles. What was my speed? So I'm going to do my 60D Street. I'm looking for speed, so I have 60 times D divided by T gives me speed. I could plug in my numbers to say 60 times 16 divided by 135 gives me 60 times 16 divided by 135 gives me a speed of 7.1 knots. So my speed made good is 7.1. So I can check that I am going a lot faster than my 6.5, which I thought I was. Whether it be wind, current, better slippage, whatever it is, I'm going faster than anticipated. Okay, so then we are moving on to our next leg. We are going to go to buoy 28. Okay, so for the next leg, we are going to buoy 29. I think I said buoy 28 earlier. It's actually buoy 29 off of Gay Head, that southwest point of Martha's Vineyard. So we are headed to buoy 29. You connect buzzards to buoy 29, just a straight line across. And the first step was to calculate our course. So once we draw our line, we can use our triangle and line it up on a meridian and the long side of the triangle on the line in question. And we have, here's 100, here's 110, and it's just shy of 105. So we have 104 as our course. We can also use our roll plotter or our parallel ruler. I used the roll plotter last time, so I'll use parallel this time. Line up on the course in question, pressure on one, and just bring it down to the center of your compass rose. Draw in your line, and then you could read our 104. So that works out. So that is our course, and our speed was 5.6, so we're slowing down a little bit. So we have our course of 104 degrees true, and our speed of 5.6 knots. And then it asked us, what is our ETA to buoy 29? So I'll put this on the whiteboard real quick. Okay, so this is what we have so far. We left the light at 10:56, and it's asking what is our ETA to the buoy. So we need to use our dividers and find our distance. Our distance won't reach all the way, so I'm going to do 5. We have 5 nautical miles, so I have from the buoy 5 plus so 2.9. So I have 7.9. I have a distance of 7.9 nautical miles from buzzards to 29. And I have a speed of 5.6 knots. So what is my ETA? I need to distance, speed, time. My distance was 7.9. My speed was 5.6. What is my time? I'm going to do the magic circle. I know it doesn't look like a circle. So we have 60 times 7.9 divided by 5.6 gives us time. So we have 60 times 7.9 divided by 5.6 gives us approximately 85 minutes. 85 minutes is equal to 1 hour, 25 minutes. So if we left buzzards at 10:56 and it took us 1 hour and 25 minutes to get there, our ETA would be 56 plus 25 doing my calculator work, I'll show you, is 81. 81 can't go in the minutes, so I have to subtract 60, gives us 21, and we carry a 1. So our ETA is 10 plus 1 plus 1 gives us 12. 12:21 is our estimated time to buoy 29. So that is number 9. And then it asks us, what is the deepest part of that we are going to pass? So this is an exercise of when we draw a course line or a track line, we need to check that track line for any hazards or things of question. So we are going to look at our track line and follow it along, just looking for our deepest point, just as an exercise. So right around here, I have a 109, a 102, and a 78, 68, 80s, 97. So I would say my 109, 102 would be my deepest point. Now when you look at these soundings, we have 109, 102, and 68. Our line, our track line, goes something like that. So we're not quite passing the 108 or 109, which is deepest, and it's getting shallower going towards our track line. So I marked it down as 108 is approximately our deepest point. So on the track line, our deepest point would be approximately right there, and then it asks us what is the latitude and longitude. So this is our practice in measuring latitude and longitude. So I like to draw my longitude and my latitude in, and then I use my divider to say that that latitude, right about there, bring it all the way over, and I have my latitude as 2123.5. For my longitude, it's just shy, right past 71, so I have down here, I know you can't see, but 07100.3. So I have my position, just an exercise in getting position. Okay, then it told us you arrived at buoy 29 at 12:15. So if we actually got here at 12:15, did we make faster or slower than our 5.6, which we had anticipated? It would be faster. We got there sooner than anticipated. So whatever my actual speed, I know that it's quicker than 5.6. It's more than 5.6. So I need to go back to calculate what my actual speed was. I don't use my 1221 anymore. I'm going to use these two times, and I don't use my speed. I'm looking for my speed. So I use my time and my distance to calculate speed. So I have to figure out the time difference. So I have 12:15 minus 10:56. We can't do 15 minus 56, so we borrow, making that an 11 and a 75. So we have 75 minus 56 gives us 19, and 11 minus 10 gives us 1. We have 1 hour and 19 minutes, and that would be 60 plus 19 would actually give us 79 minutes. So if we go to our distance is 7.9, speed is our question mark, time is 79 minutes. So we can go to our 60D street. We're looking for speed, so we have 60D divided by T gives us speed. We could plug in our numbers to say 60 times 7.9 divided by 79 gives us a speed. We get a speed of 6.0 knots. So our 6.0 was more than our 5.6, so that checks out, that our actual speed was 6.0 knots. So again, just using that 60D street a bunch of times and practicing and collecting information using that. Okay, so then we're going to move on to our next leg. Let's get started on that. Okay, so for our last leg into Martha's Vineyard, we go from buoy 29 to buoy 1. So we want to make sure we're going to the correct symbol here, the buoy, not the light. Remember, a buoy has an open circle and a diamond, where the light has a solid circle and a teardrop. So we're going to buoy 1, and we draw in our line, and first step is to put what our course is. So we can either use the triangle right on the course at 096, or we can use our parallel or ruler and bring it down to the compass to get 096. I used the wrong one. This is it. 096. There we go. Okay, so then I'm going to blow it up here on our whiteboard. Okay, so I've just blew it up here on the whiteboard. From buoy 29, we departed there at 12:15, and we were headed to buoy 1. We calculated our course to be 096 degrees true, and we have a speed of 5.6 knots. What is our ETA to buoy 1? So our first step is to calculate our distance. So what is our distance? We're going to use our dividers. Oops, here we go. There's our distance. I'm going to bring it up and say our distance is about 4.2. So now I can calculate what my ETA is using my distance and my speed. So I have distance of 4.2, speed of 5.6, and my time, my ETA, is my question. So I have 60 D equals S times T. I'm looking for t by itself, so I get 60d divided by s gives me t all by itself. So I have 60 times 4.2 divided by 5.6 gives me t. So I have 60 times 4.2 divided by 5.6 gives me a time of 45 minutes. So if I left here at 12:15 and I have 45 minutes as my transit time, my ETA would be 0, 0, carry the 1, and my ETA would be 1300. To buoy 1. So then it asks, what was our total time elapsed from Brenton Reef? So how long have we been underway? Using our ETA to our final position there. So our later time is the time of arrival, so our later time was 1300, and our departure time was 8:20 back at Brenton Reef. So 8:20 was our departure time. How long have we been underway? What was our transit time? So we start with the minutes. We can't do 0 from 20, so we borrow. 60 minus 20 gives us 40, and then 12 minus 8 gives us 4. So our time underway was 4 hours and 40 minutes. And that's the end of assignment number 10. So if you guys have any questions, please let me know. And assignment 8 and 9, we're both practicing that 60D street calculation. So no chart needed for that, just keep practicing that 60D street. All right, I will see you guys next week. Thanks.